Welcome to my video lecture based on circuit theory, paper code PCEE 301. Today's topic is condition for reciprocity and symmetry of two-port network. Myself, Kumum Banerjee, Assistant Professor of Electrical Engineering Department, Dr. Reciprocity Institute of Technology and Sports Complex. Previously, it was known as Dr. Reciprocity Degree Engineering College. This institute is under various group. In my previous lecture, we have started two modules on two-port network. In two-port network, we have seen that there are mainly two input ports and two output ports are there, and those are mainly four terminal network, and that is known as two-port network. And in two-port networks, as per knockout syllabus, there are mainly four parameters are there which we will use to concern. One is open circuit parameter, second one is short circuit parameter, third one is ABCD parameter, and fourth one is H parameter or hybrid parameter. These four parameters here basically look into it. So in this lecture we will see the condition for reciprocity and symmetry of two-port network. So let us start with the reciprocity and symmetry for two-port network. And what are the conditions? What are the things we have to keep in mind for these conditions of reciprocity and symmetry that we will learn through this lecture? So let us start with condition for reciprocity and symmetry. A network is said to be reciprocal if the ratio of the response transformed to the excitation transform is invariant to an interchange of the positions of the excitation and response of the network. So what is reciprocity? I think a network is said to be reciprocal if the ratio of response to the excitation transform is invariant to an interchange of the position of the excitation and the response of the network. A two-port network will be reciprocal if the interchange of the ideal voltage source at one port with an ideal current source at the other port does not alter the ammeter reading. That means what we are doing in two ports? We are just interchanging the ideal voltage source at one port with ideal current source at the other port, and in this condition the ammeter reading should not alter. Then we can say that this two-port network is following the reciprocity. Similarly, a two-port network is said to be symmetrical if the input and output ports can be interchanged without altering the port voltages and current. When it is called symmetrical, if the input and output ports can be interchanged without altering the port voltage and current. Okay. So if this condition persists, then we can say that the two-port network is symmetrical. So let us start with the condition in terms of Z parameter. So first we will see the condition for reciprocity in case of Z parameters. So mean that first we will put the ideal voltage source in input port, and we have sorted the output port. So we short the circuit both 2 and 2 dash, that means the output. And we have applied a voltage source Vs at the port 1 and 1 dash, that means input port. So therefore V1 equals to Vs, that means our source voltage is basically Vs, so our input voltage is Vs. And as the output port is shorted, so definitely the output voltage will be 0, so V2 is 0. And I2 dash, I2 equals to minus I2 dash, because as the path is shorted, so current is flowing in the reverse direction. So it is minus I2 dash. Now we will write the equations of Z parameters in terms of the values we have gotten in this condition. So the equation becomes Vs equals to Z11 I1 minus Z12 I2 dash. And second equation will be 0 equals to Z21 I1 minus Z22 I2 dash. And this is the two equations. Now solving these two equations for I2 dash, we are getting that the value of I2 dash will be Vs into Z21 divided by Z11 into Z22 minus Z12 into Z21. Now again we will interchange the position, that means we will put the voltage source in the output terminals and we will hold the input terminals to verify the reciprocity of this Z parameters. So when we are doing the same thing for opposite terminals, definitely the equation becomes different. So now for first input terminal the voltage becomes 0 and in output terminal the voltage becomes Vs, and input terminal current is in opposite direction, so it will be minus I1 dash, and in output terminal it will be positive I2. So we are writing the equation 0 equals to minus Z11 I1 dash plus Z12 I2 dash, and Vs equals to minus Z21 I1 dash plus Z22 I2 dash. Again we will solve these two equations, and by solving this two equation we are getting that I1 dash equals to Vs into Z12 divided by Z11 into Z22 minus Z12 into Z21. For the two-port network to be reciprocal, from the equation we can write that the condition is Z12 equals to Z21, and if these two are equal, at that case we can say that these two-port network Z parameters, they are reciprocal with each other. So the condition we have got here, that is Z12 equals to Z21. Now we will do the condition for symmetry of Z parameters. So applying a voltage Vs at port 1 dash, that means input port, and with port 2 dash is now open, and we have the equation, that is Vs equals to Z11 I1 minus Z12 into 0, because at that case our output port is open circuited. That means current cannot flow through this path, so current is 0 in this case. So from here we are getting that Z11 equals to Vs divided by I1 when I2 equals to 0. Now applying a voltage source Vs at Q2 dash, that will just the reverse we have making the condition just reverse. In Q2 dash, the voltage is applied and 1 dash, the port are open. So it becomes Z22 equals to Vs divided by I2 when I1 equals to 0. For the network to be symmetrical, the voltages and current should be same. From equation 7.3 and 7.4, we have find that the condition for symmetry is when Z11 equals to Z22, then the network is symmetrical, we can say. That means from the comparison of reciprocity and symmetry, we are getting two relations. First relation for reciprocity, that is Z12 equals to Z21, and second relation we have got, that is for symmetry, and that is equals to Z11 equals to Z22. That thing we have got from this calculation. Okay. Next we will do the same thing for Y parameters. Conditions in terms of Y parameters. So we are doing the same thing. That means for first case we will put a voltmeter and second output terminals will be shorted, and we will do the same thing for reverse side. That means secondly input side will be shorted and output side will be voltage scaling. In that way, we will do the calculations and we will put the principle of reciprocity for Y parameter also. And we are getting the condition for Y parameter, that is Y12 equals to Y21 when the network is reciprocal. And in the similar way, we have done the calculation for symmetry also. That means we have apply a voltage source in input terminal and output voltage source is open, and putting the same condition for Y parameters, we are getting the symmetry relation, and that relation is Y11 equals to Y22. Okay. Now we will doing the same thing for ABCD parameters, and we have applied the condition for reciprocity, and putting all those values in case of ABCD parameter equations, we are getting that for reciprocity, the condition for reciprocity for ABCD network, it will be AD minus BC equals to 1. At that place, the network will be reciprocal. And same thing we will do the calculation for ABCD parameter for knowing the symmetrical condition, and we are getting that when A equals to B, then the network is called symmetrical. That means we have again got two relations, one for reciprocity and another for symmetry. Reciprocity relation is AD minus BC equals to 1, and for symmetry relation it is A equals to B. And that thing we have got from this ABCD parameter. The calculation procedure is same just like of Z parameters. And I will tell you that you just practice those things in your own hand for all the reciprocity conditions and symmetrical condition for all other parameters for easier understanding of yourself. Next for condition in terms of H parameters, condition for reciprocity when it is the case of H parameters. So same calculations we have done for H parameters also, and we are getting that the condition for reciprocity is H1 equals to minus H21. That means for H parameter, the condition we have got, that is H12 equals to minus H21. At that case, the hybrid network will be reciprocal. And similar way, we have done the calculation for symmetry also, and we have got that the condition for symmetry is H11 into H22 minus H12 into H21 equals to 1, and that is the condition for symmetry of hybrid parameters or H parameters. So these are the basic relationship of reciprocity, reciprocal and symmetrical. So what are the relations? We are just brush up again. For Z parameter, the relation for reciprocity is Z12 equals to Z21, and for symmetry it is Z11 into equals to Z22. For Y parameters, reciprocity condition is Y12 equals to Y21, and condition for symmetry is Y11 equals to Y22. That means for Z parameter and Y parameter, the condition for reciprocity and condition for symmetry are similar. Okay. For ABCD parameter, it is different. In case of ABCD parameter, the condition for reciprocity becomes AD minus BC equals to 1. And for condition for symmetry, it becomes A equals to B. And for H parameters or hybrid parameters, again the relationship is quite different, and that is H12 equals to minus H21 for H parameters. And for condition for symmetry, it is also different, and that is basically H11 into H22 minus H12 into H21 equals to 1. That means similar result is for Y parameter and Z parameter, and different result for ABCD parameter and H parameters. According to the voltage current relations, these parameters are basically changing. So in short, we have making a summary of these relations for condition of symmetry and reciprocity. For Z parameter, it is Z12 equals to Z21, and for symmetry, it is Z11 equals to Z22. And for Y parameters, Y12 equals to Y21 and Y11 equals to Y22. For ABCD parameter or transmission parameter or T parameter, the relations for symmetry and reciprocity is AD minus BC equals to 1, and the condition for symmetry is A equals to T. And for H parameter, it will be H12 equals to minus H21, and condition for symmetry is H11 into H22 minus H12 into H21 equals to 1. Okay. So that is the main fact we have got from the relationship of two port parameters, and we have got the calculations of reciprocity and symmetry, and we have find these relations. Now we will see a small problem related to Y parameters. Previous lecture we have solved a problem related to Z parameters, and in this lecture we will solve a problem related to Y parameters. So solution, we consider two situations. When V1 equals to 0, that is port 1 is short circuited. In this case, no current will flow through the 2 ohm resistor. No, this is not 2 ohm, this is 20 ohm resistor. And the modified circuit is shown in figure A. by applying KCL at node 2. And this is the modified circuit, and we have applied KCL at node 2, that means in this point. Okay. And we are getting that V2 minus 0 by 10, that is, this is V2 minus 0 by 10, the current through this branch, plus V2 minus 0 by 50, V2 minus 0, because here the voltage is 0, path is shorted. So the current which will be V2 minus 0 by 50 equals to I2. So from here we have calculated that Y22 equals to 0.12 mho. Admittance unit is mho. Now we will calculate the current through I1. It will be 0 minus V2 divided by 50. So the value will be 0.02 mho. Okay. So these two values we have calculated. Now when V2 is 0, that is the port 2 is shorted, in this case no current will flow through 10 ohm resistor, and the modified circuit is shown here. Now by applying KCL at node 1, we are getting that V1 minus 0 divided by 20 plus V1 minus 0 divided by 50 equals to I. We have just applied KCL in this node, and all these values we are getting, and from there we have calculated that Y11 equals to 0.07 mho. Similar way we have done the calculation for finding I2 also, and it will be 0 minus V1 divided by 50. This branch current. 0 minus V1 divided by 50. So we are getting that I2 equals to this one. And Y21 equals to I2 by V1, that is 0.02 mho. So all the parameters we have calculated here, and the Y parameters are just like this. Y11 equals to 0.07, Y12 equals to 0.02, Y21 is 0.02 and Y22 is 0.12. These parameters we have calculated. Okay, in that way you can calculate the parameters of two-port networks. So here I have followed this lecture from the book of Reciprocity of circuit theory. You can follow other books like Reciprocity of circuit theory, that is also a good book. And also you can follow the book of Viral Chaudhary, and Reciprocity book is also there. So there are various books related to circuit theory, but in Reciprocity book you can got lots of problem solution, and you have to practice those numerical problems for easier understanding of circuit theory. Basically, circuit theory is that like a subject where you have to practice more and more numerical problems. And when you will practice more, your efficiency will be better, and you can understand this topic very easily by solving different numerical problems. So not much more for today's class. Thank you all for listening my lecture. In my next lectures, we will again continue about two-port network, and there we will discuss about the relationship between parameters like what is the relation between z parameter and y parameter, or what is the relation between z parameter with ABCD parameters. Those things we will discuss in my next lecture. So, thank you all for listening and lecture.